Hey everybody, we are going over logarithmic function context and data modeling. So that means given a set of data, can we find this logarithmic expression or formula or that relationship, okay? So let's go ahead and talk about a quick little review. Remember that logarithmic functions have independent values, or the x value, that increase proportionally. The word that we've used before is multiplicatively, while the dependent values increase at a constant rate, or they're constantly adding the same number. So for example, here in the independent value, I can see that we're multiplying by 3 every time, whereas the dependent value, or the y value, is adding 2 every time. This is kind of the textbook case of a logarithmic relationship. So remember that the proportion that or the number that we're multiplying by is also the base of that logarithmic relationship. Okay, but with that said, we're going to be using our calculator a lot. Your calculator only does what's called regression with an ln logarithmic function. So it only uses base e. What a regression is when your calculator will take a piece of data and work backwards to find the function that represents that data versus the other way around. So let's do an example number 1. It says, at the end of the school year, the classroom gets really, really warm, as you guys probably remember. Here it gets really warm as well. As the number of students increases, so does the temperature. Mr. Bean took some data last May. So as the number of students increases, so what's happening here? We see that those number of students is really just multiplying by 2 every time. And then the temperature adds 2 degrees each time. So we see that this indicates a logarithmic relationship because we're multiplying the independent and the temperature or the dependent values are adding every time. So because this is a logarithmic relationship, we can use this to find an equation. So we're going to use the regression equation to model the situation. Again, this means that we can use our calculator to take this model that we've determined that it's logarithmic and find that equation. So here's your steps, okay? You need to take your calculator out for sure. You have to work through this with me. There's a lot of steps. Make sure that you're practicing this. It's the only way that you're going to remember how to do this, okay? So in your calculator, here we go. Let me show you how to do this. Whoops. Show you my calculator. Here's my calculator. While you're also working through this with me, you're going to hit the stat button, which is right here next to the left-hand cursor. After stat, we're going to scroll over 1 to the right, and you're going to click the calc. Okay, so 1 to the right, hit the calc, and we see that we're going to use our linear regression, or excuse me, ln regression, which is option 9, ln regression, to find that. In order to use that though, we need to make sure that we have values in our list. So let's go ahead and put values in our list. So you're going to hit, to put the values in the list, you're going to hit second stat. And this stat key is right here, and then you're going to go, sorry, not second stat, just stat. And then you're going to, under the first one, which is edit, which means you're going to input a list, so hit edit for number 1. And right now my list 1 is blank. We're going to make list 1 those x values. So those x values were 2, 4, 8, and 16. Go ahead and type those in. And now we're going to go to list 2, which were the temperature values, or the y values. So they were 67, 69, 71, and 73. Okay, so now that we've got list 1 and list 2, we can go back to our ln regression to come up with the equation that is working. Okay, so again, we're going to go back to second stat, just stat, calculate, option number 9. So we've got our X values are in list 1, Y values are in list 2. We're going to store our regression. You always want to store it. So in order to store it, you are going to click your vars key. So that's underneath this, the down key. Vars is right here. And scroll over 1 to Y vars. Number 1 is function. And you're going to tell it to store it in Y1, which is that function. And then when we go back to here, so we've got our X list is list 1, Y list is list 2. You're going to store your regression equation into your Y1. That'll really, really help you later on, you'll see. Now scroll down, hit calculate. What this does is it tells you, hey, this is the equation for the data you gave specifically. So here we go. Here's our regression equation. It says y equals a plus b ln x, where a is 65 and b is 2.885. Go ahead and round it to the nearest third decimal place. Okay, so that we know that's going to be y equals 65 plus 2.885. So next one down, according to the model, what's the temperature if there's 35 students? So either you can write this by hand, where y equals a, which is 65, plus b, which is 2.885 rounded, times the ln of 35. Okay, and you can calculate that separately, or you can literally do this in your calculator using what you just stored. So you can go to second table, and we see that these values here are from our y equals that we just stored in there. So go back to table. You can scroll down to 35. And we see 35 gives us a value of 75.259, or I'm going to give you the ultimate hack. You can go to this screen and you can click vars, y vars, function 1, put it in function notation of, so parentheses 35. This will be y1 of 35, where x is 35, hit enter, and it gives you that value. Okay, so let me go ahead and write down those values for you. Okay, so if you want to use your function notation, so to put it directly into the function notation, once you've already sorted in, again, you're going to vars over 1 to y vars, hit option 1, which is function, and then click the function that you stored it under, hit enter. That gives you that value to use for function notation, and then plug in your x value. Hit enter, and it gives you that value at that function notation. Okay, so we go y1 of 35 equals 75.259. And again, this would be the temperature if there's 35 students, so this is our temperature in degrees. There's a few different ways you can find that. According to the model, how many students are there if the temperature reaches 85 degrees? So let's look at that. Okay, so remember, if the temp is 85, how do we show that? Well, we know that the temperature is that y value. So we see T, the temperature, or y is 85 degrees when A, which is 65, plus B, which is 2.885, times the ln of x. Okay, where x is the number of students. So we need to solve for x. We're going to do this by hand, so we're going to subtract over that 65. So we end up with, I'm going to bring it over here, 20 equals 2.885 ln x. Divide both sides by that 2.885. Before you divide it, I would just leave it whole because you don't want to round until the very end, so just leave it whole. In order to get rid of that ln, you're going to raise it by an e to both sides. So we get x equals e to the 20 divided by 2.885. Plug that into your calculator, round it to the nearest third decimal place, and we get 1012.740. Remember to always round it at the very end. Don't round it before you get to the end of the equation. So that's approximately 1,113 students. The good news is you can't really fit that number of students into a classroom, so you don't have to really worry about the classroom getting to 85 degrees. All right, example number 2. I want you to pause and try this one on your own using that last example as your guide. I want you to try this with your calculator. Using your calculator and being comfortable with it is critical for this section. So go ahead and hit pause and work through it. All right, welcome back. Let's check to see if you got this correct. So looking at this data, the temperature of his coffee is increasing here, or varying, I should say, and it's increasing every time here, okay? So let's see what our logarithmic regression is. So again, we're going to let the calculator do the work. So remember, again, we're going to, let me pull up my calculator. So we're going to hit Stat, Edit to get those lists. We're going to clear out the lists from before. You could also technically just use new lists if you don't want to clear them out. You don't have to use list 1 and list 2. But we're going to let list 1 be the temperature. So the temperatures were 95, 90.6, 86.5, 82, 78, and 75. Okay, once I hit enter, I'm now going to put in my list 2, which was the time in minutes. So 0 minutes, 3 minutes, 6, 9, and 12, and then 15 minutes. We also want to make sure that our lists have the same amount of data. Make sure that you check your lists through. Once we have that, we're going to go ahead and find that regression equation. So again, you're going to go to Stat, Calc, and then go to option number 9, which is the natural log regression. Again, it's asking you, where's your X list? We know we put ours in list 1. If you would put it in a different list, you would change that. Our Y variables are in list 2. We're going to store it in a regression equation. I can either plug it back into Y1 or plug it into somewhere else. Remember, we do that hitting the vars key, go to Y vars, number 1, and then select which function you want to store it into. So we're going to store ours in function 1. You can store yours in a different one if you like. Go ahead and hit calculate. It's done. So we see here that our regression model is Y equals A, which is 283.471, we're rounding, plus B, which is negative 62.246 times the ln of X, okay? Again, that's rounded, but the one that's in your calculator is not rounded. It is exact. It can store all that data in there for you. So how long will it take for the morning coffee to be 70 degrees? So looking at how long it'll take for it to be 70 degrees, we're going to plug in Y1 of 70. And so we're going to go just vars 1. And then we're going to plug in 70 here. And we see that it'll take 19.02 minutes to get that coffee to drop down to 70 degrees. Okay, looking at this next bit. It says people measure loudness in terms of decibels. So hopefully you've heard of decibels before. That's how they measure how loud something is, where D of I is the decibel level and I is the intensity of the sound. 10 to the negative 12 is the intensity of the quietest sound a human can hear. The question, so they give us the function here. What's the intensity of the sound of the school fire alarm if it registers at 100 decibels? So this is what we know. This 100 decibels is D of I, okay? Where D of I is the decibel level. So we know 100 is the decibel level equals 10 times the log of the intensity level, all divided by 10 to the negative 12. We want to know the intensity level, so we want to know what this is. So let's get it by itself. First things first, let's divide by that 10. So we end up with 100 divided by 10 is 10 equals the log of I over 10 to the negative 12th power. To get rid of that log, we're going to raise both sides by a power of 10. So we end up with 10 to the 10, which is right here, equals I over 10 to the negative 12. To get that I by itself, we're going to multiply both sides by 10 to the negative 12. So remember those exponent rules, 10 to the negative 12 times 10 to the 10 means because they have the same base number, we're going to add the exponents. Negative 12 plus 10 is negative 2. 10 to the negative 2 is the same as saying 1 over 10 to the 2, which is 100. So 1/100th, or 0.01, is the intensity level of that alarm, which it doesn't sound like much, but in comparison to 10 to the negative 12, which is like 11 decimal places with the 1, this is much louder. Okay, for this last one, example number 4, I want you to pause the video right here. Go ahead and try it on your own, and then come back and check. All right, thanks for pausing and trying it. Let's check your work. So Mr. Brutz wants to save for a new Lamborghini. He currently has $50,000 in an account that pays interest continuously and will need $300,000 in total. Remember, this is our continuously compounded interest formula, A equals PE to the RT. If he leaves his money in the account for 12 years, and doesn't add anything, what interest rate would he need to achieve his goal? So let's see, we need him to have $300,000 for that new Lamborghini. He wants to invest $50,000 right now and leave it alone. We don't know the rate, but we know he wants to leave it alone for 12 years. So we've plugged this all in, and now we have to solve for that R rate, unknown percentage rate. So first things first, again, we know we have to get rid of this E somehow, but before we do that, we're going to divide both sides by 50,000. And then we've got 6 equals E to the 12 times R. Take the natural log of both sides, and we get 12R equals the natural log of 6. Divide both sides by 12. Plug that into your calculator, and we get R is approximately 0.149, which is equal to 14.9%, which is actually a pretty high rate of investment. There are some really good investments that can get there, but most do not average that high. So hopefully he can find some more money to invest, because he's going to need a little bit more than what he's got. All right, I'll see you back in class. Thanks.